I will help host our session and host our Yale professor, Dr. Mark Ashton. Before he starts, I just want to acknowledge this is our first of a weekly series that we're starting off. And I want to admit that this is a bit of an experiment for us, and it's going to be really important as we kick this off to have your help to be engaged so we can make the most of our time together. So just to give you a sense of our format, we're going to ask Dr. Ashton to first give a brief 10 or 15-minute presentation for everyone. And it might be helpful at the start of when he gets started for everyone to put their microphone on mute so that we don't have background noise. And then when he's done with his presentation, then we'll open up for discussion and your questions. You could either use your microphone for the questions, or you could also feel free to use the group chat if you want, and then we can go through questions that are listed in the group chat. So whatever makes you feel more comfortable, but we really hope to involve everybody in a conversation and for you to be able to ask our expert, Dr. Mark Ashton, questions that you might have about the presentation, or even maybe things that are not in the presentation that you'd like him to answer for you, or for us to kind of think about for a future weekly session that we'll do. So with that brief introduction, I want to invite Dr. Ashton to help us all learn about the value of trees for water that we use.
Well, thank you very much, Colleen, and I hope you can all hear me. I am a professor at Yale, and my expertise is in what's a discipline called silviculture, which is how we manage and grow forests for different kinds and values that society wants. And this topic is a very important topic that most people don't recognize how enormously valuable forests are to the production of clean water that society utilizes for drinking, for agriculture, for fisheries, for all the necessities that we think of that we want for life. So I am going to be talking primarily about the water that we drink. Particularly here in the Northeast, it's incredibly important to recognize that the water that we drink comes from our own forests, or the forests that remain surrounding the cities that we live in. So let me just try and emphasize some of the importance of this. This is actually the largest man-made or human-made lake in the nation. This is actually a reservoir. It's a reservoir where all the water is collected from the surrounding forests and serves the water supply for the city of Boston and all the surrounding towns and cities around Boston. It's about 9 miles in length, and it takes, for example, for the water to go in one end, it takes about 9 years to circulate in the reservoir before it's piped by an aqueduct to the cities and towns that it serves. So this reservoir is called the Quabbin, and it's surrounded by 90,000 acres of forest land that is managed by the city by the state of Massachusetts and the city of Boston. It's surrounded by 90,000 acres of forest land that act to collect the water from rainfall that moves through the forest into the streams and then into this reservoir, where it is then piped without any kind of other kind of filtration, any kind of engineered filtration, through to the citizens of Boston and all the surrounding towns, and also to part of the city of Springfield. Okay, so I'm going to give you a little bit more of a story here about how valuable water is, how water is, and watersheds. What is a watershed? I'll explain that. How water is managed for drinking water supplies, primarily for all sorts of cities in the Northeast or Eastern North America, and also Western North America. If you think about all the big cities in Eastern North America and Western North America, they are serviced by reservoirs. And those reservoirs, if you do not protect the watershed, the area where the rain falls down onto the ground and then collects into the streams and then flows into the reservoir, if you don't protect that, you have very dirty water to drink. So many cities have served to try and protect those watersheds. And I'll expressly talk about the watersheds and the water that we drink here in the city of New Haven and all the surrounding towns. So let's just talk about how valuable fresh water is to us for society. The first thing I'd like to show you, if you see my cursor, is when I talk about a watershed, I'm talking about this red dotted line that I am basically moving all the way around here, all the high ground, and all the water on the high ground flows downward through gravity on the ground into streams and then into a dam usually, which collects that water. That is the watershed. And the watershed for the actual dam is this little dotted line. And if you put gas tanks in here, houses in here, all sorts of other buildings in here, you are potentially contaminating the water that runs in the form of rainfall onto the ground, into the stream, and into the reservoir. So this is the reservoir. This is the watershed for the reservoir. This dashed line is the watershed for the whole area downstream, including the city of New Haven, for example. You can imagine the reservoirs are upstream of the city of New Haven, and they flow downstream into, this is the New Haven Harbor, and this could be Long Island Sound. This is actually a Canadian example. And if you're looking at the value of this water, how much of this water do you think this, what it would be defined as surface water, is on the earth? It is a fraction of the amount of water that we are looking at. I'm going to go over to this diagram here, and what you can see here is that 95% or 96% of the Earth's water is salty. It's really not usable for us as fresh drinking water. Only about 2.5% is what would be defined as fresh drinking water. Now, of that 2.5%, you're going to have to think about this mathematics carefully, very carefully. Of that 2.5%, okay, only 1.2%, okay, is actually accessible to us. The rest is in the form of groundwater or in the form of glaciers. Glaciers, which, if you think about Antarctica and you think about Arctica, they store an enormous amount of water. And when you think about climate change, that's what we're worried about when we're thinking about climate change. We're thinking about this enormous volume of water potentially melting into the oceans and raising the ocean sea levels. But of that 1.2%, again, only a fraction, this top area here, maybe 20% in the form of rivers, in the form of soil, in the form of lakes, is accessible for us to use for mankind or humankind in terms of drinking, in terms of irrigation for agriculture. The rest is actually frozen, particularly in the boreal, in the Arctic, in the Antarctic, in the soil itself. It's just frozen, and only 3% is actually in the atmosphere. So the atmosphere, what makes the rain, and then the rain is stored in some part of the active hydrological cycle in about 22%, 25% of what's available in terms of fresh water. So when you think about this, only a small amount of fresh water is available for us to capture in a particular way, to clean, and to make available to humanity. So now let's go to the Regional Water Authority, the South Central Regional Water Authority, which is where we get our drinking water from. And all those, this is the state of Connecticut, and what you see here, all the green signifies the towns that's New Haven in the center, and then you can think of Branford and East Haven and North Haven and Hamden, West Haven and Orange. All those towns obtain their drinking water from the South Central Connecticut Regional Water Authority. And it's in those same towns that the water falls, and there are reservoirs. And then the pink that you see are also towns, Madison, for example, where the South Central Connecticut Regional Water Authority has reservoirs or has watersheds that allows the water authority to gather the water and to pipe it to New Haven into reservoirs. So the pink towns are not so like for this is the citizenry for the Regional Water Authority. So this Regional Water Authority, where we all get our water supply from, comprise 20 district towns and cities. A million in the state of Connecticut get their water supply, their drinking water supply, from watersheds. Okay, fire departments, health departments, they all get their drinking water supply from watersheds. So there's about 50 million gallons per day that we utilize there. And this is the oldest watersheds or set of watersheds is managed in the country for drinking water. It's actually the oldest forest managed for drinking water supply for the citizenry of South Central Connecticut, New Haven, and the it has a very ancient, over 100 years, what was originally the New Haven Water Company. So let me tell you a little bit more about this. So here we are. Now we've zoomed in, and now we're looking at the watersheds. These are the blue lines, okay? In the towns and the cities that the Regional Water Company, the Regional Water Authority, manages water for us. And the green is the forest. And inside that green are the reservoirs. There are 4 big reservoirs and a groundwater well that supplies all the drinking water for all the towns that you see around here. Wallingford, Prospect, Bethany, Hamden, Woodbridge, New Haven, West Haven, Orange, East Haven, Branford, North Branford, all get their drinking water supply from these watersheds, and therefore these forests within these towns. So it's very, very important. And it's 26,000 acres. It's an enormous amount of land that is actually protected by what was the old New Haven Water Company and now is the kind of South Central Regional Water Authority that gets these watersheds, they protect them, and then they allow the water to flow through the forest into the reservoirs, and so the reservoirs have clean drinking water. There are no buildings, no gas tanks, no septic systems, no houses in those green areas. They're protected. They act, because of that protection, to filter the water through the trees and into the streams and into the reservoirs. 50 million gallons of water a day for us. So let me tell you the difference, okay? So here is Lake Gaylord. It's a reservoir. And this is all the forest watershed that is protected all the way around. This is the outlet, there's the dam. And this is actually in North Brantford. And so what you can see here is this is fully protected, and it gets most of its water from this watershed that you see. You can see all the built up areas outside of the watershed. And then it also gets a lot of its water from Madison. And you remember that pink area that I showed you in a prior slide, in a prior PowerPoint? That pink area also has watershed, and it basically captures that water and then pipes it underneath to the biggest reservoir for the City of New Haven, for the South Central Regional Water Authority, which is Lake Gaillard, that you've probably never seen unless you fly over in an aeroplane. And this is clean drinking water as compared to Lake Whitney. Lake Whitney used to be very clean drinking water before it was all built up. See all the town, this is all Hamden and New Haven. If you compared the water quality of Lake Whitney, and that's on the right, right-hand side here, okay, as compared to the Lake Gaillard, okay, which is protected versus not protected, 48% of this watershed is protected, only 6% of this watershed is protected. And when I say protected, protected from houses, protected from roads, protected from septic systems, protected from gasoline. If you think about where you get your gas, they're from gas tanks that are buried in the ground. They can leak. So 48% protected versus 6% protected. If you're looking, if you're looking at the color and the quality of the water, the area that has a much greater amount of protected area, you can see that the color is much higher. It's got a lower color. In other words, it's clearer. The turbidity, when you're looking at the turbidity, it is much lower. That means the sort of the brown, the amount of sediment in the water is 1 as compared to 3. The chlorophyll, as a measure of algae, the greenness, the little tiny plants in the water, is much lower in the protected watershed as compared to the unprotected. And so when you think about the water that comes out of the reservoir, excuse me, when it comes out of the water that comes out of the reservoir for Lake Gaillard, okay, you can see the blueness. Goodness gracious, sorry about this. It is a nice crystal clear blue. In fact, when you just look at Lake Whitney, it is a brownish. So it's much cleaner, and it costs a lot less in delivery to the drinking water supply. $220 in terms of a million gallons delivered as compared to 600. So it pays for itself by protecting the water. So what do forests do? They act as filters. They are the filtration system that cleans the water from rainfall. First of all, you have a protected watershed. You can't build in it. That is a source of pollution for the reservoir. You don't want gasoline into the reservoir. You don't want septic system, microbial biomass, sewage going into the reservoir. You don't want road runoff going into the reservoir. So if you protect it by saying, we want forest, that's a very good way of ensuring a very resilient, long-term, clean drinking water supply for the citizenry of the region. The forest also does a filtration. If you think about rainfall, you have lots of pollutants in the rain. You have mercury. You have all sorts of acidic compounds like nitrogen and nitrogen dioxide. This is from car exhausts or from power plants. These are all emitted into the air, and then when the rain comes down, those little particulates get dissolved in the rain. They get absorbed into the rainfall and moved into the forest. The forest, first of all, captures the particulates, and those particulates are held in the litter, in the organic matter of the soil. They are bound, they are captured there, and they are essentially not movable into the streams. The forest also, through the roots and the trees, the roots take up the nitrogen, which is seen as a fertilizer, okay? For water and for drinking water, it's a pollutant. But for trees, what you apply to grass, for example, nitrogen, it's a fertilizer. It's taken up by the trees. It is held by the trees. It makes the forest more active, more fast growing. So you can see all this little diagram here. You can see atmospheric deposition in terms of water, in terms of snow. It has to pass through the leaves. It can get captured through the leaves. It then goes into the ground. It gets captured by the soil. And then the very clean water moves through the soil, looking at my arrow, into the soil as subsurface. It doesn't go overland. It goes through the soil, into the streams, and then down into the reservoir. So forests play a very important, no-cost way of filtering even the rain to make much cleaner drinking water than just rain that was captured without what trees could do. They filter the water. It is nature's filtration system. Okay, how do they do this? Well, this is an example, and this is what forestry does in these forested landscapes, in these watersheds with forests. Foresters, and foresters are people who manage forests for people to provide different kinds of goods, products, paper, wood, fruits, nuts, everything that you can think about that you might eat or you might build with, but also all sorts of kinds of service values that you'll hear about in the remaining kinds of lectures that we have. One of them is water, and forests provide water, clean drinking water. So the city of Boston, it has 90,000 acres of forest land, and it has nature's filtration system entirely to provide clean drinking water for the citizenry of Boston and all the surrounding towns that make up Boston. The city of Portland, Oregon, the city of Portland, Maine, the city of Seattle, Washington, the city of New York City. All these big cities have upstream watersheds, which are all forested, and they provide clean drinking water. And all that drinking water is managed by foresters to supply water into reservoirs for people. And what do? They manage the forest to create all those different layers that I was talking about, a multi-layered forest of different age classes, of different species compositions. And the reason why we want different layers of forest, stratification we call it, and different species, is to make for a very resilient forest to capture water in times of disturbance. What happens if there's a tornado? What happens if there's a hurricane? What happens if there's lots of insects and disease, or a big amount of air pollution? Or what happens with climate change? We want to build a forest in which there's a lot of species and a lot of different size classes of trees that can act as a filter. So if the large trees fall down or the large trees die, we have small trees that can grow up immediately. So what the foresters do is they manage a forest like this, relatively simple in structure, just of big trees, and they move it to a forest that looks like this, big trees and small trees. And so it's a very resilient, vigorous, young growing forest with big trees, old trees, and small trees, and it's a very efficient filter. That's my lecture. Questions?
Thanks so much, Dr. Ashton. We do have one question listed on the group chat, and then maybe Marlene, you might like to open it up to your students or anybody else on the call who would like to pose a question either through the group chat, or if you want to take your microphone off of mute, you could just ask us. But I see here, Dr. Ashton, there's a question that's notes here from Chris Williams asking, less chlorophyll in protected areas is a result of less algae, and then he asks, which is a result of fewer nutrients in the water. So he's wanting to understand that part.
Yes, it is. If you have lots of nitrogen, particularly nitrogen, which is a pollutant in water bodies, it's not a pollutant in terms of vegetation, it's a fertilizer. So if you allow the nitrogen to be captured by the plants, then the nitrogen won't flow into the water. Nitrogen can basically, it will act as a fertilizer to make all the algae bloom, which is a pollutant for us as a drinking water supply. It can often lead, with all that nitrogen, it can often lead to what's called anoxia. It'll starve the water from oxygen, which will basically starve the fish from oxygen. So it'll be poorly oxygenated. It'll be poorer in quality and more polluted. Nitrogen is a pollutant for us. In fact, it's a health problem for small babies, for example, who are very sensitive to high nitrogen water.
Great. There's another question from Matt Vines asking, how does land management and ownership patterns make acquisition and management of upstream forests for water quality different or more difficult maybe than in the West where public lands are more prevalent?
Well, Matt Vines, I think that you're an overgrown high school student. That was a complicated question. So it's amazing how Boston and New York City and all, if you think about Hartford and New Haven in particular, they have big watersheds that were all protected, and yet they are in some of the most populous regions of America. As compared to, I mentioned the cities out west, Portland, Oregon, and actually also San Francisco. Portland, Oregon, and as Portland, Seattle, and San Francisco all get their drinking water from the wildlands that were protected back in the early 1900s by the government under the National Forest Service and all the National Forest Service lands and the national parks. There are reservoirs inside the Forest Service lands, the national forest lands. So they were protected because they were basically wild originally, and they were protected by the federal government, the American government. But that's not the case here in New England or Eastern North America. Eastern North America, nothing was protected. What was happening in the 1800s was the Industrial Revolution. The New Haven Water Company was trying to create and provide water, for example, for the citizenry of New Haven, and yet it was extremely dirty because it was all farmland, and of course parts of New Haven were all industrial. You know, Eli Whitney, for example. So what happened? It was a sense of circumstance, very lucky circumstance, all in, particularly in Eastern North America, with Boston, with New York, with Hartford, with New Haven. People moved off their farmlands to work in the cities in the industrialization of those cities, which made those farmlands very cheap to purchase. And the old New Haven Water Company purchased at a very price, at just the right time, the Great Depression, much of it, in the 1920s and 1930s, large amounts of forest land around reservoirs that they built at that time. And for example, the biggest human-made reservoir, the Quabbin which services the city of Boston. It's one reservoir for the whole city and all its surroundings, was built in the 1930s. And all that land was purchased by what's called eminent domain. You'd never be able to do that now. Too controversial. But there were very few people living on the land surrounding the reservoir they built in central Massachusetts. And 90,000 acres was acquired. In New Haven, about 30,000 acres was acquired, basically through land purchase, not so much through eminent domain, around 4 big reservoirs, of which 3 they managed to protect, 1 they didn't. I showed you Lake Whitney. That was really never protected. And so it has to have a filtration system built by people that costs billions of dollars.
Can I interrupt, Mark? I'm sorry. I just want to interject that there's a question from Katura asking, is Lake Whitney still serving areas in New Haven?
Aha. It is, but only as a backup because it's the poorest water quality. And you can look at the filtration plant next time you go by on Whitney Avenue. As you go by the dam of Lake Whitney, on the other side of the dam is this big silvery looking modern building. And that is the filtration plant. And it's the filtration plant that cost the regional water authority a lot of money. And they only use it on special times of the year, once a week approximately, when the other reservoirs are running out or they're low. So it's only used on special backup circumstances because all the other reservoirs have much better drinking water quality. Lake Gaylord, which is in North Branford, and Lake Saltonstall in East Haven, I believe, and also in Branford. Those are much cleaner drinking water supplies because they protected the watershed, because they purchased the land. They could never purchase the land anymore, okay? So what they have protected is here to stay, hopefully. They cannot sell. It's in a statute by the state of Connecticut.
Mark, we have another question asking what kind of recreation takes place in those protected lands, and can people get access to them?
Well, unfortunately, those watersheds, as you can imagine, are protected. So people, there might be special access at special places. For example, different cities have different rules and regulations, but they're all fairly stringent. These are not parks, because if they were, you do not want dogs, for example, defecating in those watersheds, because that's your drinking water supply, right? And in certain cities, they're not that the trees are the filtration system. So there are all sorts of ways of protecting and trying to keep recreation to a very, very low level. In some places, you can walk, okay? For example, the 90,000 acres, if you're looking to recreate, perhaps the better place to recreate is that the regional water authority doesn't really allow much recreation. It has other ways of engaging the community. It has a way of allowing citizenry to tap maple trees for syrup, for example, or to cut firewood. And you'd have to get special permission to do that. But by and large, the citizenry is not really allowed access to those clean drinking watersheds, just because, well, when you think about it, and now it's very easy in terms of terrorism to perhaps potentially pollute this whole drinking water supply. So a lot of these watersheds are quite strictly protected. But if you go up to Massachusetts and the city and you go to the Quabbin Reservoir, maybe your parents can take you on a drive. You go up 91 and cut across to the Quabbin, and you go to Belchertown. They have a park at the end of the reservoir. It's called Quabbin Park in Belchertown, and you can go in and you can actually look at the reservoir It is a massive reservoir. It's a feat in terms of human engineering, and they have a museum, and they can tell you all about it. And it's about a 3,000-acre wooded park, and they put it at the end of the reservoir because, as you can imagine, the reservoir is at the end of the watershed. So everything below the reservoir is the park, and so they have protected it, and it's for people. So different cities have different places you can go. If you go to Lake Whitney, there's a museum there managed, where the dam is, managed by the Regional Water Authority that you should go and have a look at.
That's great. We only have a couple minutes left, and I'm wondering, Marlene, do you want to check, do your students have any other questions, or does anybody else on the call have a last question or two before we wrap up our first series?
If not, I just need the attendance. I just need to see who's in. I did get a lot of students are chiming in through email saying they were unable, so I'm going to have to walk them through it for our next series.
Okay, I can also follow up with you because we can see some of the participants' names that I think are from your class, so we can follow up with you with that. Does any of the participants, anybody have any last questions?
I have some concluding remarks, okay?
Okay, let's go to that, Mark.
So first of all, class, I'd really like to thank you for participating. I hope you recognize the value of forests just in terms of drinking water supply, because if you think about it, you might have heard of other cities that are in very dire straits. The city of Atlanta never protected its drinking water supply. And then for the cities like New Orleans and St. Louis, these are all drinking water from the Mississippi. And this water is some of the most polluted water in the United States because of all the farmland runoff, fertilizer, and pollutants that go into the Mississippi watershed. And so they have to basically take this water and then purify it. And it costs billions upon billions of dollars to maintain that clean drinking water or to clean it. And they still cannot clean it. If you think about all the medicines that we actually take, and then they go into the sewerage system. Many of these cities are drinking their own water, the water that has actually been cleaned or semi-cleaned from sewer treatment plants that are inside the watersheds. And so the medicines like blood pressure medicines and coffee, you can always actually detect how clean the drinking water is by whether you can detect coffee, because we all have coffee in the morning, and then it all comes out, and it goes into a sewer system or a septic system, and then we can detect how polluted the water is by how much caffeine we are now re-drinking. Just a little message and a little foreboding. Protect your watersheds.
That's so great, Dr. Ashton. Thank you so much. Others are chiming in about what a wonderful lesson and how much we gain and learn from you. So thank you so much. I hope everyone will tune in again next week. We'll have Dr. Thomas Easley with us talking about our relationship to the environment. But again, thank you, Dr. Ashton, for kicking off the series and helping us to organize this weekly event. Thank you very much.
Thank you very much. Bye-bye.
Bye, everyone.